Light comes from the sun and is a form of solar energy. It enables us to see everything around us. We are able to see objects around us because they reflect light towards our eye. This light is then focused on the retina as an image, which will be upside down and diminished in size. Light can be luminous, like the light from the sun, or non-luminous, like the moon, which doesn't produce light, but merely reflects the light from the sun. But in all cases, whether it be natural light, such as lightning, or man-made light, such as candles or light bulbs, the light spreads outwards in every direction unless it is refocused by a lens or a reflector. Light travels in straight lines as long as it remains in one medium. This is called the rectilinear propagation of light. In a vacuum, such as space, light travels at 300 million meters per second. It cannot travel faster than this, but it can travel more slowly. For instance, as light enters a denser medium, such as air, glass, or water, then these higher density materials will slow it down. For example, light travelling through air has an approximate speed of 295 million meters per second. Light entering ophthalmic crown glass is slowed down to approximately 195 million meters per second. If light enters a dense medium such as water or glass at an angle incident to the surface, then the ray of light will refract or bend. However, the extent of the refraction will depend on the density of the medium. One with a low density, such as water, will cause a minimum amount of refraction. One with a high density, such as clear glass or a high index lens material, will cause considerable refraction. If you have two media of varying density, the one with a low density is called the rarer of the two. The one with a higher density is called the denser of the two. When light passes from a rare to a dense medium, for instance from air to glass or water, it is refracted towards the normal, an imaginary line at right angles to the surface. When the opposite occurs and it travels from glass or water into air, it is bent away from the normal. It is reflected light from the objects all around us that enable us to see them. Light is always reflected in a scattered manner, allowing light to enter the eye and focus on the retina. When light is reflected from an object, the incident ray, the normal, and the reflected ray all lie on the same plane. The angle of reflection is equal to the angle of incidence. Light can also be absorbed. It can be transmitted, and it contains colours. Though we see light as white, it is made up of many colours called the visible light spectrum. Different colours are produced by the different wavelengths that make up the visible portion of the electromagnetic spectrum. All lens materials disperse light to some degree, but some have what is known as low dispersion and others have a high dispersion. Those with a high dispersion have a low constringency. Those with a low dispersion have what is called a high constringency, meaning that the material will hold the light together. The word constringens comes from the word to constrain, and is represented numerically by the Abbe number of the lens material. Materials with a higher Abbe number constrain light more, and as a result provide spectacles with clearer optics. It is those clearer optics that enable the wearer to look out into the world with confidence.